Hello friends, today we will discuss about the differential equation, and if we want to study about differential equation, then we should have knowledge of the differentiation as well as integration, because in differential equation we will use the concept of differentiation as well as integration. So first of all we will try to define the what is the differential equation. So differential equation is just differentiation of the dependent variable with respect to the dependent uh, differentiation of the dependent variable with respect to the independent variables, and there may be one variables or two variables and many variables, but in our syllabus there will be only one independent variable and one dependent variables, and regarding that we will have to discuss, and this one there will be some constant which define the differential equation. For example, if I am saying that dy by dx plus py is equal to q, you can take this is also differential equation, because y is a I'm considering that y is a function of x, and y is depending on the x, so x is independent and y is the dependent variables, or you can define according to our choice. So this is a differential equation, and it's maybe that someone can choose another type of differential equations, maybe like d square y upon dx square plus dy by dx plus y is equal to c, or maybe we can multiply by some constant, we add some constant. So these are the differential equation. Actually, there are many types of there are two types of differential equation, ordinary differential equation and partial differential equation. But in our syllabus, mainly we will discuss about the ordinary differential equation, and there are a lot of types to solve those problems. So we will try to discuss all these things. But before that, we are going to discuss about the some basic definition which are involved in this topic, differential equation. So first of all, let's me define about the order and degree of a differential equation. So what is the order and what is the degree? Order is the highest differentiation of the any differential equation. For example, I am going to say that dy by dx is equal to c, some constant. So here is only one order, because dy by dx is a one time derivative. And if another one is taking the example of double derivative of y with respect to x plus dy by dx plus y is equal to constant. So here order is the 2, because here we have differentiated the dependent variable two times. So this is the maximum times of differentiation which are present. So highest order of the differentiation which are present in that differential equation is the order of the differential equation. So highest order derivative which are present in the differential equation, that are the um, order of the differential equation. Let's define the degree. What is the degree of the differential equation? Degree is little bit different from the order. So when we define order, at that time when we are going to define the degree, at that time we have to keep in mind that we should not forget the definition of order, because when we try to find out the degree of any differential equation, at that time we will also take the help of order of the differential equation. For example, I am going to say that dy by dx is equal to c, any constant. So what will be the degree of the differential equation? So degree is a simple term which are present in the highest order derivative terms. Here dy by dx is one order, so the power which are present in dy by dx, that is only one. So one will be the degree. It's maybe some people can consider that dy by dx and there is power 1 by 2 is equal to c. So what will be the uh, degree here? It's maybe that you can say that 1 by 2, but no, here will be the order degree will be, we will have to just square both sides, we will get dy by dx is equal to c square. So dy by dx, now there will be power 1, because dy by dx is equal to c square, so power will be 1. We have to keep in mind that degree cannot be any fraction type of part. Degree always be integer number. If this is not present in the highest order derivative, then we will have to manipulate, we have to square, we have to multiply by any numbers. We have to multiply means just try to square, or power 3 power 4, we have to do in both sides and try to manipulate in such a way that highest order derivative become free from the fraction type of the power, that will be only integer type of the power. So these are the degree. So let's take some another example. For example, d square y upon dx square is equal to 1 plus dy by dx upon some constant. So here you are getting that there is a highest order is a 2. The double derivative is present here. So in double derivative the power is only 1. So the degree will be 1. This also will be possible that another question can be made like this: d square y upon dx square to the power 3 by 2 is equal to dy by dx plus some constant. So here dy by here power is 3 by 2, so we will have to remove this 3 by 2 because that power will be only uh, integer in the highest order derivative. So what we will do, we will just do the squaring both side and we will get the power 3, which is the highest order in the left side, which is highest order derivative. So the degree will be 3 in this case. We will square both sides. So in this way we can remove the fraction part. So these are some things that define the degree. In the when we solve some questions in NCRT or any mains level questions, generally they ask this type of questions. So we will have to take care of those things. So we are going to ahead and we are discussing about which type of question will be asked in differential equation and how we can make approach to solve those questions. Sometimes it happens that they just give you some equation. For example, they are giving you equation like x square plus y square is equal to a square. This is a simple equation of the circle, and they will ask you what is the differential, how we can represent this circle by a differential equation. So what we will do, we will just try to find out the differentiation of this equation and try to remove the constant term which are present in that particular differential equation. For example, I am taking x square plus y square is equal to a square. Okay, so a square is the constant and x and y are the variables. So what I will do, I will just try to find out the dy by dx in such a way that a can be eliminated. So here I will get 2x plus 2y, y dash means dy by dx, 2y, y dash is equal to 0. And in this way I can manipulate and I can write these terms in terms of y dash, which will be the differential equation which represents a general uh, circle. And this may be that they can there can be two variables. For example, I can take x minus a square plus y minus b square is equal to r square. So here are three constant a, b and r. So how many times I will have to find out the differentiation? Three times, because mainly when we are solving differential equation we have to only remove the constant term which are present in the differential equation. After removing those constant terms, what will be remain? We just that will be the differential equation. So generally it happens that if there are three constant, we have to find out the derivative three times. If there are two constant, we have to find out derivative two times. So that as you know that if there are two unknown and two equation, then we can solve. So in the same thing we have to apply here, that if there are three constant, we have to make three equations so that we can remove all these constant terms and we can write down the differential equation. So always we have to keep these things in our mind. It's maybe they can take example like parabola y square is equal to 4x. So what we will do here, we will simply remove a, 2y, y dash is equal to 4a. So 4a, so we will take the value of a from here and put this value of a in the previous original equation of the parabola, and we will get the differential equation. So these are some basic things, and if we keep these things in our mind, then we can solve the questions. And there are so many problems which are given in CRT, and there are so many questions which are asked in the JMN's advanced examination. So by applying all these things, we can solve those questions. So these are the things which when the equation is given and we are trying to find out the what can be the possible differential equation. Now this can also be possible that they can give you differential equation and they will ask you that which type of curve, which type of lines or any things which can be represented by this differential equation. For example, if I am saying to you that dy by dx is equal to c, so what is this? If I just try to integrate both sides with respect to x, I will get y is equal to cx plus d is, c and d are the constant. So this is representing line. So it's maybe that the different type of differential equation can be given, and you have to find out that this is the differential equation of which type of lines or which type of curves, maybe anything. So we will also discuss that some differential equation is given to us, and we will try to find out the solution of the differential equation. So when we solve this equation, then there will be many types of method that we solve in under ordinary differential equation. But mainly in our 11th, 12th and mains level, there are some fixed method to of solving differential equation. First method is that the separation of the variable. For example, for example, if I am going to say that y square dx is equal to x square dy. So you are getting my point that the term of x square is present in the right side but dx in left side. So we will just try to separate the variable of x in one side and the variable of y on another side, and dx will be this side. Or I just want to say that the terms of x will be with the dx, in terms of y maybe y square y to the power 3 by 2, maybe any terms of y will be with dy, and at that time constant may be present in any side. It does not matter, but we have to take care that variables will be in the if x is there, then x terms of x will be present in with dx, and terms of y will be present with the dy, and we have to solve that equation. We just simply find out the integration and we will get the answer of our question. This is the variable separation. And there are also some another method that some differential equation is given which is homogeneous. So at that time we just try to find try to just substitute some values in place of y by x or x by y. It is little bit tough to understand, but not so much tough. If we take a simple example, then it can be very easy to understand. Generally there will be, if we are dividing all the coefficient by x, x square or x cube, or maybe any higher order of the any higher terms of the x, or maybe y. So we will get that differential equation in form of y by x or x by y. So we will replace this y by x by v or x by y by v, and then we find out the differentiation of these terms with respect to x or y, how this is required, and then manipulate all the values there and put the values there, solve that equation, and then again put the value of v in form of y by x or x by y, what we have considered in the beginning, and then we get the solution of our problem. So this is a homogeneous equation. And another method which is very favorite and generally they ask questions from this topic, that is linear differential equation, and it has very uh, definite form like dy by dx plus py is equal to q, where p and q are the function of x or maybe any constant number. And sometimes also can be asked that dx by dy plus px is equal to q. So if we are sure about dy by dx, then dx by dy can be solved easily. It is not a problem, but we have to remember only one: dy by dx plus py is equal to q. Okay. So how we will solve? Generally, some differential equation is given, and if you just try to divide some variables by some numbers, then we will get this term dy by dx py is equal to q. This will be easily shown, and sometimes it may be possible that we will have to consider something, then we get the terms of dy by dx. So what we will do in this type of differential equation, we try to find out the integral factor. So integral factor is equal to e to the power p dx, where p is the function of x or constant, which I have already told you that this is present in dy by dx plus py is equal to q. From here we will try to find out integral factor, and this integral factor will be used further to solve the differential equation. So what will be the form of that? A form will be y multiplied by integral factor is equal to integration integral q integral factor dx plus c, and we solve this this equation, and we will get the solution, which will be the solution of the differential equation. So this is the way that we can solve the differential equations, and there are so many problems which are given in our NCERT, and we can solve those problems one by one. So these are something that I had in my mind, and I thought that it would be better to just share with you. So this will also help me to figure out that where I'm committing the mistakes and how we can learn. I can learn from my own mistake, because in this time we are in so high or so little bit things, and it will also help me to improve how to teach and how to communicate with the students. So these are something that I had in my mind, and I thought that it would be better to share, to discuss, which can help me. So these were things that I had. So thank you, friends.